welcome everyone. Very nice laptop stand. How it's called? Rooster?
Next stand.
It looks like Rooster. So yeah, that looks really nice. Welcome back. I like that. At least some people came back to this series. Today we will be talking about state processes, let it crash, and OTP. Does anyone remember what we have talked about last time? Because it was 3 weeks ago or something, I don't remember exactly. So we went through overview of functional programming paradigm. We touched history of Erlang and Elixir. We've seen and talked about some companies who uses Erlang or Elixir, and as you can see here, I added a little bit more names like Goldman Sachs, Nintendo, for example, and multiplayer that is built in Nintendo Switch is actually built with Erlang. All the messages are processed by Erlang there, Financial Times, Discord, etc. And we went also through the basics of Elixir syntax, lists, modules, pattern matching, multiple clauses functions, and the pipe operator. And touched a little bit the topic of how to think in a functional way. Does anyone wants to tell me what's happening in this program? I don't know if you learned anything about Elixir or maybe it's just obvious. So any hand?
Quiz. It's pretty clear, yeah.
So Nikita, tell us please.
Okay, let's see. Count binary, non. Okay, like at least I can read this pipe thing. So convert string to down case. Pretty clear. Now it's down case string split by some regular expression.
Yeah, you don't need to go into details of regex.
I'm not going to go into regular expressions here. Then trim what's the English word for this?
It's basically we are splitting the string, and if the pieces we split.
I just don't remember the name of the symbol.
It's a keyword list, and this is atom, trim atom.
Yeah, and okay, yeah. Then okay, that's more interesting. I guess that puts.
What we get after string split? So we've got the string.
Yeah.
So after the string split, we already got the list of.
So in map, I would guess all the pieces are going to be converted into something like JavaScript object.
Not really.
No, wait. No, they're going to be just string. And when it's reduced, they're going to be converted into something like dictionary.
Yes, you have the good guess. Any other guesses? What happens in the reduce?
It's map.
Yeah, it's map. But it's hash map. In Elixir, it's a map.
Maybe it just counts as a word.
Yeah.
Yes, exactly. So it counts the words. We start with the empty map. Every step, every iteration, the function, the anonymous function, fn word ec receives the word, a piece that we got from the list previously. Ec is accumulator, which at the first iteration is empty map. And what we do in this function, we put into this map, into this accumulator, some value. So if and value, the key for that value is going to be the word, and the value we are going to increase by 1, or it's going to be 0 if we are meeting that word for the first time. Okay, good. So it's clear for some people. And that's, by the way, why I like the pipe operator. Even if you don't know exactly what's happening or details of any function, you can guess from the steps what's happening, what's the transformation happening. Regarding the spec that you started to read, it actually, so as I told you before, the previous time, Elixir doesn't have types, at least yet, and type system, but we do have specs. And here they are not that strong, and you can break them. They are mostly used by special library, distillery. No, not distillery. Sorry, I forgot the name. It helps to automatically analyze your source code and give you some alerts or notifications that, oh, you said that your function is going to receive binaries only. Why you're passing here an integer? And it's gonna inform you.
Sounds like TypeScript.
But, yeah, exactly. When are they applied?
So while you're coding, if you have language server protocol installed, while you're coding, your editor is gonna show you these kind of notifications, plus also during the compilation.
Nice. Yeah.
So yeah, if you have this library added. Also here you can see the nice that you can put documentation for the functions right in the source code, and for module, as you can say that there is no documentation. But probably I will be able to show you how it works. So today it's gonna be like a restaurant. So for the starter, we're gonna talk about how to keep state in this immutable world and what are the processes. The main course is Beam and OTP, and if we have some time for the dessert, I'll touch on system architecture and let it crash philosophy topics. So let's start with state and processes. Slides go away, and we go here. Probably I need brainwashing, make the starter as you prefer VS Code. Let's try VS Code, but probably I will have some issues with this because my hands already have muscle memory for terminal and V. Okay, how to control? Oh, terminal. Yeah, I still remember it. So it's nice. It's nice. Let me try to make it a little bit bigger for you. And we will be talking about processes, messages, and recursion. Let's ask ourselves a question. If everything in Elixir is a pipeline, that transform an input data through some steps into the output, how or where can we store the state?
Outside the pipeline.
Nice guess, but I don't remember if I told you last time what I love about Elixir, that when you see the def, you know that the scope is clear. You don't have access to the outside world from this def. To be honest, you have, and probably we can touch on this, but in general, you don't have the global variables or anything like that. But the answer to this is simple. We can use processes. Processes, it's very tiny building blocks in the Beam virtual machine, in the Erlang virtual machine. Actually, when you spawn a new process in Erlang virtual machine, it takes only 600 bytes at start. So when it's just created, not exactly 600 bytes, but 300 words. And then it depends on your architecture, how many exactly bytes it's gonna take in the memory. But usually it's like 600 bytes. In addition to processes, by the way, that's the thing that we have global access to. In addition to processes and messages between them, we can also use ETS or DTS tables to store and share data between the processes. But we won't go into this topic today. That's maybe it's going to be your homework, if you like. In Elixir, all code runs inside processes. Processes are isolated from each other. They run concurrent to one another and communicate via message passing. Processes are not only the basis for concurrency in Elixir, but they also provide the means for building distributed and fault-tolerant programs. Important information. Elixir processes should not be confused with operating system processes. Probably I told this last time, but it's important to understand. Processes in Elixir are extremely lightweight in terms of memory and CPU, even compared to threads that you can see in many other languages. Because of this, it's not uncommon to have tens or even hundreds of thousands of processes running on one machine. It's just a matter of if you have enough memory for this machine. Let's start from some basics. To show you some basics, I need to start IEX. IEX is interactive Elixir. If you have Elixir installed, you can play around on your machine with this. So it actually just command line. You can play around. You can run some code here. So for example, 1 plus 2. I usually like to use IEX as my calculator. So, you know, like to calculate salary or something, how much I receive. So, yeah. But now we are talking not about salaries. We are talking about Elixir code. And the basic mechanism for spawning new processes is the auto-imported spawn function. Spawn takes a function which it will execute in another process. So, spawn fn anonymous function 1 plus 2 and we see nothing. So the return value from that function is just some PID, process ID, some internal ID. Let's try to grab it. So spawn fn 1 plus 2 and as you can see, it's another PID. So we spawned another process. What we can do with this PID? We can use process module, for example, and check if that process is alive. What do you think? Is it alive?
No.
Good guess, because yeah, the function just executed and the process is dead. Good? Good. We can check if we are alive, probably, and answer some existential questions. So, self, by the way, returns the PID of the current process. Wow. Yes, we are alive. Yeah. So as you can see, self returns the PID of the current process. Good. So far, so good. But this is the very basics. Now we need to learn how to send and receive messages between the processes. Let's try this. So let's try to self a message to ourselves. Hello world. So we are sending. That's another auto-imported function. It takes one argument, the PID, and another, and the second argument, whatever. So you can send whatever to the other process. Good. And it returns what it had sent. But we are now in the process of interactive Elixir. We have not received yet. So this is not receiving. It's just what the send function returned, the return value. We need to use this construction. Hello message. As you can see here, we are using pattern matching. So we are trying world. We are not interested really in the message. Want match. Let's say like that. As you can see, after this code, the current process, it received and processed this message. It went here and world became a message variable, and now we've got it. Also, important thing, when we send a message to some process, it goes into the process mailbox. So there is some memory part which is called mailbox. So and the messages, they can live for a while in this mailbox, like you see here. So the message is stored in the process mailbox. The receive block goes through the current process mailbox. It searches for a message that matches any of the given patterns, as you can see here. And receive supports guards in many clauses, such as case. The process that sends the message does not block on send. It puts the message in the recipient's mailbox and continues to run. So that's why you can see that here we can, after sending it, we are not blocked. It's totally asynchronous. And the current process will wait until a matching message arrives. We can also specify some timeout for the receive function. Let me show you a little bit more complicated example, which also takes into consideration, so it's just nicer to put it into a module. We have some state keeper, def loop, it receives some state. So we define some public function that receives some initial state, or just some state, let's name it like that. What in the body of this function? We have the receive do construction, which has 3 clauses with pattern matching. One expects a tuple of take number atom plus something, then report state. And what happens? Let's first see what happens here. So we've got PID. By the way, that's another variant of spawn. It might also take not anonymous function, but the name of the module, then atom as the name of the public function, and list of arguments that is gonna be passed to that function. So here, for example, we are trying to execute this, and we're gonna pass 0 to state. Here, what happens? We are sending to that PID take number and waiting for signal back or message back. As you can see, it counts. So already something happens with the state. We can also send another message to that same PID. PID, I don't know how to correctly pronounce it. So every time we send the report state, it doesn't change the state. It just reports it, and that's all. What's so interesting about this construction? It's a recursion. As you can see here, every time we receive a message, either it's some known message to the process, like take a number or report state, or any other message. So here the underscore means that we don't care about what the message was. What it does, it runs itself with the state. And here, for example, in this clause, take a number, what happens? We just add +1 to the state. We send back a message to the process that sent us some message and run again. So we are waiting again. Every time this function executes, get invoked, it checks and waits while the new message appears in the mailbox. If it anything that it can do about it, it's gonna run accordingly. So, do you have any questions regarding this?
What about infinity recursion? If we pass some unexpected message, it will go to the default branch and will run it forever, maybe.
If you are going to to send the messages forever.
Okay.
So the receive construction, it gets one message,
Okay.
processes it, and it disappears from the mailbox.
Okay.
You're not going to be in the endless loop here.
Okay. So everything is removed just automatically.
Yeah, yeah. Basically, it's also like the endless loop until your virtual machine is running. So if you started the process like that, though it doesn't take any resources. While there is no message in the mailbox, it just waits for it. It's in blocked state. It doesn't consume CPU or anything. It just waits.
So it's like parked.
Okay.
On the ID stored probably.
So
And some whatever metadata.
it uses some memory, of course.
Yeah.
But basically, the virtual machines won't invoke this function until the message comes to its inbox.
Okay. Yeah.
So that's why you can have millions of processes and they won't consume all your CPU. Because if there are no messages coming, nothing happens.
A question like maybe there is one like does Erlang virtual machine can be distributed over several?
Yes.
Okay. Yeah, that's a good answer.
Yes, that's one of the best parts. We won't touch that topic today. Probably we will touch it briefly next time. But yes, you can have the distributed system. The best part regarding that thing, that this send function, it doesn't care where it exactly sends the message. So you just need to have the PID. PID can be from the other computer, maybe on the other end of the world. And if it has the connection, the nodes connected to each other, you just use send, PID, and that message gonna go
It's
there.
like abstracted away. Like
Yes, it's totally
to the ultimate limit.
Yeah, not to the ultimate. When you're building a cluster of Erlang machines, Erlang nodes, as far as I know, I never built myself such a big one, only played with a few virtual machines in my local network. But when you're building the production one, it's better to avoid to have more than 50 machines, 50 nodes in one, because then something that we touched last time regarding the distributed systems happen, because every machine, every node, they have connection and keep connection to all other nodes.
Okay.
But it can work, but if you have the high loaded system,
It's quite a lot. Anyway.
yeah, it's gonna be too much. Any other questions regarding this receive do thing? How we keep the state?
How to stop this loop?
Good question. Good question. Let's try it. Let's support. We don't care about where it comes from. And not exit reason. Let's try 0. I'm not sure that it's gonna work, but let's see. And let's send that signal. So something happened. Probably this process is gonna die now. Yes, as you can see, we are trying to send the message there, but the process is dead by that time. Here we start it again, it works again, so we can report some state. That's, by the way, important part that I mentioned in the text, but did not show you here. This after. It likes you are given in milliseconds the timeout. For how long the current process is gonna wait for anything comes to mailbox. If nothing, then it just continues work. That's on how to avoid the endless waiting times. One more thing. Agent module. Let me show it to you here. Agent. So, and so that's the documentation website. If you remember, I really like their documentation. And what Agent does? Agent is a simple module. It gives you a simple abstraction of this boilerplate that we have done here. So you can say agent start. You pass some anonymous function or non-anonymous if you want to. And the return value of that function is going to be the initial state for that process, for that agent process. Here, for example. By the way, here you can see an example how you can run Erlang code from Elixir. Sys is the module in Erlang. And you can easily run functions from Erlang like that. And it helps you to introspect what's happening with the process. For example, we can get its state by the PID. It's actually, let's better to call it as PID. Also, this module, what the abstraction it gives functions like update, and it expects the PID of the agent that was previously started, and function that receives the current state, does something to that state, and that's all. So
It's like a state model.
yeah. So here it's just simple counter. So far so good? Good. Because now we are going to talk a little bit more further about processes. Let's clean this. We are going to talk about linking and links between the processes. The majority of time we spawn processes in Elixir and we spawn them as linked processes. Previously, I showed you just spawn something and nothing happens to the parent process. Let me show it again. So fn, but let's maybe do something interesting. Let's do simulate some exception that happens. Okay, that's just the log message. Nothing happened to the parent process. And as we can see, PID 113. Okay, let's do this thing. Spawn link, raise, oops, and too much stuff happened, right? So let me try to explain what happened. As you can see, we still receive the similar log message, but because it was linked to the current parent process, the parent process also got exited because of the exception in one of his children. Why it happens and why it's important, you will see a little bit later. But you can check that now we have another PID. So IX automatically restarted itself. That's why we see again. But it got killed. Why it got killed? Because IX was not ready to get the race. You can be ready and you can catch these things, and probably we'll see it. So because the processes are linked, we see the message saying the parent process, which is the shell process, have received an exit signal from another, causing shell to terminate. IX detects this situation and starts a new shell.
I have a question though. So it's guaranteed that failing process is going to be restarted, right?
It's not guaranteed, but we will touch.
But okay, so it's not. Well, maybe
It's only regarding IEX, so we will touch that topic, and later, during today's workshop, you will understand why it restarts.
My second question would be like about this endless restart loop if something fails over again.
That might happen in production, and actually you need to be care about that. But you just, when you're building a system with this actor model and messages between the processes, you should predict such a situation.
So there are ways to mitigate it. Like,
Yeah.
Okay.
The best part about OTP, I'm running a little bit further, that it has lots of abstraction, and people, they were working with these kind of problems for 30 plus years. So the library contains lots of solutions.
Are there like any static analysis tools that can predict this kind
If I'm not mistaken, yes.
Okay, cool.
Okay. Processes, that's outro for the starter part. Processes and links play an important role when building fault-tolerant systems. Elixir processes are isolated and don't share anything by default. Therefore, a failure in a process will never crash or corrupt the state of another process. It's also funny that we are all Russian speaking here, but we are continuing in English because I prepared my workshop in English. Links, however, allow processes to establish a relationship in case of failure. We often link our processes to supervisors, which will detect when a process dies and start a new process in its place, if you configured it to do that. So let's raise a level of abstraction, and let's take a look at the OTP library. Let me close these. And so some beginning. How to show it to you? No, let's go back here. Some new file. Elixir. That's something that I'll need to show you. OTP, it's Open Telecommunication Platform, that it was called in the beginning, but nowadays it's just too generic, too abstract, and it's not really about telecommunication anymore. So nowadays most of the people refer to it just as OTP abbreviation. That's all. That's, by the way, one of the official names for Erlang. It's Erlang/OTP, because it comes with this platform. OTP is an awesome set of tools and libraries that Elixir inherits from Erlang, a programming language on whose virtual machine it runs. OTP contains a lot of stuff such as Erlang compiler, databases, taste framework, profiler, debugging tools. If you remember that slide from Sasha Yurich talk that I showed in the previous workshop, that you can build your whole product using only Erlang tools without any other stuff involved. However, when we talk about OTP in the context of Elixir, we usually mean the Erlang actor model that is based on lightweight processes. And it's the basis, the foundation, what makes Elixir so efficient. As you may assume, many processes follow similar patterns. To wait for a message, some kind of a message, to do something to its state, and response. Or maybe not response. And to abstract over these patterns, we use behaviors, a special type of modules. Behaviors in Elixir and Erlang, it's a way to separate and abstract the generic part of a component here, which becomes the behavior module, from the specific part, which becomes the callback module. Do you know something similar in C++, for example? Or in Java, you can have an interface, or in TypeScript, you can have an interface which defines which functions the class should have. So behavior is a little bit like that. You define what callbacks your module is going to have, the specific implementation, and what the specification of this function is going to be. And in the real module, you just say, okay, I'm going to implement this behavior, and it also like the a helper to compiler to tell you if any of callbacks you still have to implement. So you can, it's much deeper topic. You can have optional callbacks, some other stuff, but it's at the surface it's like that. We won't go into further details, but we need to know about behavior's existence to move further. So, OTP provides a few those abstractions over standardized processes types. The most common one is GAN server, or GAN server. How would you pronounce it? GAN server. GAN, whatever. And it's a behavior model for implementing the server of a client-server relations. It's a process like any other Elixir processes. It can be used to keep state, execute code asynchronously, and so on. So keeping state, it's the very basic usage of GAN server, and it's basically better to use agent for if you just need to keep state, update it simply, something like that. So GAN server, and you will see in a few minutes, it's a little bit more complicated thing. And it will have a standard set of interface functions and include functionality for tracing, error reporting, and it will also fit into supervision tree. So let's make our hands dirty again, and let's learn something about mix. So mix is the tool that does a lot of things in Elixir world. Maybe you can think about it like a make, but for make you always need to write the make file. But mix contains lots of standard tasks. For example, mix new is gonna create the new project with some structure in it. And let's create a new project that named kingdom. -- sub, that's the key that's gonna affect the generation of that project. One of the most important changes it does, it adds the application file and it connects. That's important for us. That's not really important for us right now, what's happening under the hood, but it's we need this to continue. So let's go to the kingdom and let's overview what we've got here. So mix EXS. EXS is by the way the file extension for Elixir script. Also not very important. Here for people from JavaScript world, it might look like a package JSON. For people from other worlds, I don't know what it might look like. But it defines some important constants, some names, and it also tells what is gonna be executed when you compile this project and when you run it in production.
But is it like correct Elixir executable code, or
what?
Is it Elixir executable code or something different?
It's Elixir. So def
So
module.
It's like just the code, just code.
Yeah, it's just the code. And for example, look here. So the function project, it returns some keyword list for upper usage, for the system usage maybe. It has the key start permanent, and it's gonna be false or true. It depends on the running of this code. Here, for example, these deps dependencies, it's gonna run the function that is defined in the same module. Here you can list just all the dependencies for your project that you might need.
I remember your words about like Lisp and Elixir. So it's called this data again.
yeah, so we have some readme, we have git ignore formatter. One of the best features of mix tool, which I like the most, it also and Elixir, because mix comes with Elixir, and with mix you get for free the style formatting tool. So it has some style guides like built in, and you just run mix format and it takes all your Elixir source code or the inputs that you defined here, and it's gonna format it according to these style guides. It has some tests. You might look like they might look like that, and some files. So, for example, the module kingdom with some documentation, the function hello.
It's actually so much Lisp.
Regarding the application file, we will touch it later. This Elixir ls, it is getting generated by my language server, so it's not important what's there. Let's take a look. Maybe I want to show you one important thing, which I also like regarding Elixir. So if we start IAX like that, it's gonna run the blank IAX session. But we can tell it uppercase S and mix, and it's gonna run, it's gonna compile the current project. If you run this command in the root of the project with mix exs file, it's gonna compile it, and for example, you're gonna have access to the functions that you defined and to the modules that you defined here. So it's compiled. What I really wanted to show to you, that for example in IAX you have the helper H. H means help. Documentation for kingdom. Documentation for kingdom. Let's get some help for hello. So everything that you write here using just special notation, it right away gets just under your hand. That's the best part. Also the best part that, for example, anything that you see here in the official documentation website, it's also being generated from the source code files. So you can have the same like, hkernel, and read. So you don't even need an internet connection if you work with Elixir. Only if you prefer to see nicely formatted website. But all this information, it just goes here, and you can use Markdown. And more than that, but I won't touch this. It can even run the code from the documentation, and you can run the tests. No, I cannot resist myself. Let me show it to you. So in the kingdom test, we have the doc test command or whatever, and see. Let's see. So mix test. 2 tests. They passed. But as you can see, we see only 1 test here. What happens? The other test is the documentational test. And when you're writing the documentation, it's also a nice touch to give an examples of how your code is going to work, how your function is going to work, how it's going to be used. So here you provide like, if you run in IAX session kingdom hello, it's going to return the world atom. Let's change it. Makes test. So your documentation is also your tests, just in another world. Nice. So yeah, now we change this. If we change the function itself, it's also gonna fail because now the other test is failing. But okay, let's continue. let's continue. Let me take a look at my notes. Let's create. So now we are going to use the Gen server that I showed you before. Let's clear this a little bit. Let's create the new file. We will call it treasury. So every kingdom should have a treasury, right? So why ours is not going to have it? Kingdom. That's why. Yes. In VS Code it's tab. I told you my muscle memory for my fingers are for Vim. Treasury. And what we're gonna do here? We are going to tell that we are going to use the Gen server behavior as I showed you before. So when you define a behavior, then in the module that, where you want to implement this behavior, you use. Sorry for tautology. What it's gonna make me, as you can see here, it's gonna tell me. It happens when you have the language server protocol installed and it works. So it's gonna tell you that function init required by behavior against server, and you have not implemented. So please implement it. For now, we can inject this, but our implementation is not gonna be very different from this. So we need to implement the init function that's gonna take some initial state for that process, and it must return the tuple with atom and initial state value. So far so good. But let's add some more actions. Let's add handle cast. I'll write some code and then I'll explain what happens here. Balance do no repli balance plus amount. Minus amount, and let's call it withdraw balance. Yeah, and one more thing, we will also use the handle call to get balance, yeah, balance like that, balance do. Here we will return reply balance. What do you see here? The handle cast and handle call are callbacks that are defined by Gen server, and which you can use to implement your own handlers for your own messages. Like you have seen, we used receive, which look like case, this pattern or that. Here you can also see that we are using the pattern matching on arguments to process this kind of messages, or this kind of messages. The second parameter here, oh, by the way, here I forgot that handle call takes 3 parameters. Handle cast takes 2 arguments, some message and the current state of that process. So here our state is the balance. We called it as balance. And cast is used usually to make asynchronous calls to the process when the caller process is not expecting any message back. So it can just send and that's all. The handle call thing, it actually blocks the caller process, and it's gonna wait for some return value from the server. Let's see how we can use it. Let me return my here. Okay. ixsmix. I want to pattern match to see that we really start in the server. Start a link. Kingdom treasury, and let's say that we are going to pass 0. So we've got some PID here. We can use again the module gen server PID to send the message. Store under the hood of this function invocations. It actually uses the same send message, receive loop, etc. But it's abstracted away from our usage. We can ensure that something happened to the balance. Yes. We can again do that. So it keeps the balance. But it would be better to add some nice API for our even internal clients of our code base, because it's just too bad to write code like that. So let's do it. Def open. So again, server start. Okay. Start link. Name module. So that's interesting thing. At the compilation phase, this like underscore module underscore is going to be replaced by the current module name. So it's just some shorthand. Def store amount. And why I'm using a name here, I will show you in a moment. Again, server cast module store amount. Withdraw and let's call it as get balance. We do not need anything. So I also prefer, that's my maybe personal preferences, I prefer to call this part as client API and this part as gen servers kitchen. Even though that we have this function defined as public ones, in the head of Erlang or Elixir developer, for me it's something hidden. So something private, and I don't really need to use them if I have the nice client API defined. It's actually like a favor of original developer who tells you what is intended to be used from this module. So let's save it. Let's recompile that code. And now we can say kingdom treasury open, but we need its PID. No, we don't need the PID. Sorry. That's why we use this key name and module. When we start a server like that, now we don't need actually its PID. We can send the messages to that module by some name. So here we can use the module, but it can be my something. Then just something that will show it something unique in your current system. Okay, so kingdom, treasury, get balance, 0. Store, 3 something. Get balance, so we are changing it. One more. Basically what we have done manually, now we are doing through the nice API. And it also allows the developer to hide kind of internal implementation. So you, as a user of that model, you are not really interested in what the messages you are sending. So you are interested in the business logic that you are going to use. And this is how we hide the implementation details. So yeah, I showed you how it works, but you might ask what happens, and we are coming to that supervisor thing slowly. What happens, just a second, and we will wrap up. What happens if the server crashes? Let's simulate this. Def crash. Sorry. I'm also solving some tasks in Ruby now, and they don't have do now in my head. it just yeah. Call module apocalypse. By the way, here, for example, you see I misformatted it. Let me show you the magic. No? It VS Code reformats it automatically on save. So it's in the Vim. I can do it even while I'm editing. Sorry about that. I also need to handle this. Def handle call. Handle call apocalypse. We are not interested where it comes from, and we are actually not interested in the state. We are interested in raising something. IX kingdom treasury open. Crash. Again, we've got restarted lots of things. By the way, what I mentioned before, Gen server also provides you a better log messages, better stacks. You better know what was happening and where using this. It also even shows you the last state. So if your login system collects this data, it helps you to understand what was in the process that led it to be crashed eventually. Yeah. So let's pause now because we've got some food here, and we will continue. So everyone is here. What we have seen here. So we can crash our process, and yeah, we lose the state, we lose the process, and everybody dies. So let's go home now. But what you have seen here, by the way, that we start application console, then we manually start treasuries process, and only after that we can use it. You may wonder, is it really how think supposed to work, so much manual labor shall be involved. Letting Treasury run without a supervision is a little bit irresponsible and a good way to lose your funds or your head. So, thankfully, OTP provides us a supervisor behavior. Supervisors, they can start and shut down applications. They provide fault tolerance by restarting crashed processes, Nikita, and they can be used to make a hierarchical supervision structure called a supervision tree. So let's equip our Treasury application with a supervisor. Let's how to create the new file here. New file, Treasury. Let's call it supervisor.ex def module use supervisor. Simple enough. We also define start link function here, init arg do. We say supervisor start link here. We will also use that shortcut module. It's not really important right now. We call it module. And we need to implement init. We are not interested really in what we are getting here, but we have to define it like that because the init function callback must be defined with one argument. And we need to write the children specification. Children specification, it's a list of modules that this supervisor is gonna to start. It can be modules like our Treasury, Gen server. It can be a module that implements behavior of an agent. Or it can be another supervisor. So, as you remember my previous words, it can be a tree of supervisors and everything like that. So, let's say, I already started the map. So, ID, we need it here, kingdom, it can be anything, but we can use just the name of the module. And the other option, what to start, kingdom treasury. We want to execute the open function, and the open function, as you remember, it doesn't need any arguments, so the empty list here. And supervisor, init, children. Here, the interesting thing, so as you can see, init receives a list of child specification to initialize and a set of options. So one of the options that you will see in lots of places is the strategy that is going to be used by this supervisor for its children. 1 for 1 means that for any of the child who dies, sorry for that, but children sometimes die, it's gonna restart its copy. So we also need, so we wrote this file, this supervisor, but it's not going to start automatically right away. We need to tell the application to start. By the way, do you see some similarity?
Yeah.
But it just, the difference that it uses application. So it's similar to supervisor, but it's a little bit higher module for OTP applications. And here we need to say kingdom treasury supervisor. It also, we don't need to pass anything here. Okay. Now we are ready to see some magic. So let's restart. As you can see, it compiled a couple of files. And guess what? We can have. So our treasury got automatically started by its supervisor. So supervisor got started by the application, and this got started automatically by its supervisor. What happens if it crashes? Okay, it crashed, and if you can notice, it did not crash the IEX because it crashed. The supervisor caught it trapped the exit of its child, and it did not allow it to go further. And the interesting thing that it automatically restarted it. Though it's all good. However, even that supervisor restarts the process, it doesn't restore its state before the crash. And to be honest, it's not really a supervisor's job to do that. So supervisor just checks what kind of children it has to run, what number of them it has to run, and things like that. Children, so the processes, the server processes, usually they might implement some logic of how to restore the state by themselves. And it's also important to understand that this state will exist in the VM, so while VM is running. Probably you want to persist their state in some database. And yeah, so there are lots of different views and strategies on this. We can even use some internal database in Erlang, like I mentioned in the beginning, ETS or DTS. You can think of this like embedded database, but it's not SQL database. It works with tuples, records. It has some weird syntax to to run queries, but it's possible to use it, and many of libraries actually use it internally to keep their state. So we have only scratched the surface of OTP and looked at the GAN server behavior. I can tell you that OTP provides more specific and specialized abstractions like GAN server for implementing server-client-server relation, GAN state M implementing state machines, GAN event implementing event handling, supervisor, and supervision tree, and in addition these behaviors, they are implemented on Erlang side, but in Elixir we also have task. It's a little bit less abstraction than an agent, if I'm not mistaken, but I never used it by myself, maybe only in some exercises. Agent for simple abstraction around the state. Dynamic supervisor that start children dynamically. For example, you might have a pool of workers that gonna be started automatically to run on some task in parallel, and then it can just also put them down. Put down kids, not that good. Sounds not that good. Partition supervisor also, it helps. It provides some abstraction if you have some bottlenecks in number of running processes, so you can provide some rules how to partition your workers. Registry, that's important thing. So in our examples, I used this module to simplify how we can send messages to the process. But registry, it's it's a key value storage, which is can be used and must be used if you are building some distributed thing. There are also registers for distributed systems as libraries. And also as library there is GAN stage. It helps to make code for producers and consumers.
Registry, is it persistent, like it's saved somewhere?
If you make it, yes, but
Not by default.
not by default.
Okay.
It exists in the virtual machine while it's running. Good. That was the main course, and we have a little bit of time for the dessert. Let me check.
Can I ask another question though about registry? So are there any pluggable ways of making it persistent?
Let's check. So it's easy.
Okay, yeah, nice.
Developers to look one or more processes with a given key. Associated can be used for different purposes. Name lookups, storing properties, transparently partitioned. Probably there is no out of the box.
Okay.
But
I mean, it's pretty cool anyway. So
note that the registry, by the way, uses ETS table plus 2 ETS tables per partition. So that's one of the examples of module that use internal database.
Okay.
Let me check what's in my slides. So system architecture. Yeah. Good. I need to show probably just one picture from the slides that I have prepared myself. In the Beam virtual machine, when it is getting executed, it looks a little bit similar to this picture. So there is some main application controller. You can configure it. You almost never do it manually. So when you use the mix tool, you never go that deep into the configuration details. It does this application controller configuration file for you automatically. Only some geeks and Erlang experts go into this file to tune it. I've just looked into it, never touched. So, and it knows which application masters you need, which applications it must run. These application masters or applications, they, as you define them, the children specifications, they know what to run. And they are building their supervisor trees. As a reminder, the supervision trees, they supposed to automatically restart and keep the system running. The best part about this, by the way, that how to formulate that. Oh, we will formulate when I talk in a minute regarding the let it crash philosophy. But let me tell you the next. So the concept behind supervision trees, it's a little bit complex, but as you can see, you can just imagine them like a binary tree or something. We can run applications as I showed you manually, but it's acceptable way of doing this. Though OTP provides some special stuff like the application controller, which is hidden from us, but we can get into it. OTP drives us through the way of building these applications. I have some details on how it is built, but I do not want to touch on this. So just this particular part. Anyway, when someone decides they want to start an application, the application controller, often noted as AC in OTP, starts an application master. The application master is in fact two processes taking charge of each individual application. They set it up and act like a middleman in between your application's top supervisor and the application controller. OTP is a bureaucracy, and we have many layers of middle management. I won't get into the details of what happens in there, as most Erlang/Elixir developers will never actually need to care about that, as I told you. And very little documentation exists. The code is the documentation. Just know that the application master acts a bit like the app's nanny, a pretty insane nanny. It looks over its children and grandchildren, and when things go awry, it goes berserk and terminates its whole family tree. Brutally killing children is a common topic among Erlangers. So yeah, an Erlang virtual machine with a bunch of applications might look like, as I showed you on this diagram. Let me also maybe show you an interesting thing. So CD workspace Lexin, I wanted to show it to you. So as mix. So it's the real application, my Lexin Mobi service. But what I wanted to show it here to you, there is a library. By the way, last time probably you asked me if there is some GUI applications written in Erlang or Elixir. And this is one of the examples. So it is built on WX widgets. And it basically gives us an overview of to the internals of virtual machine, what's happening here. We can check, for example, the supervision trees of different. So this is the list of applications. Like on this application master slide. So this is the list of applications, and every of these applications, they have their own supervision tree. Sometimes they need it, sometimes they don't need it. Anyway, as you can see, they have sometimes a bigger tree or not that big tree. Mix has its own. Logger even runs as a separate application in Erlang. Kernel application is always running in a virtual machine in Erlang. It has their network stack running as an application. So yeah, this tool you can use to see what. So lots of internal information, and you can use it to debug your application. The best part regarding this, that you can use that tool in a distributed system. If you have a connection to your production node, for example, you can reach it to it. You can run IAX on your machine, connect to the remote node, and run the observer for that node. And then you're going to see what's happening in production. Yeah, so some of these methodics. Good. Let it crash philosophy. While other languages would require you to use catch or handle exceptions, in C, C++, JavaScript, we always do that, like try, etc. In Elixir, we are actually fine with letting processes fail because we accept supervisors to properly restart them. And all your prior programming experience might be telling you, could we just guarantee the server process does not crash in the first place? Elixir developers, they tend to refer to those practices as defensive programming. We don't do defensive programming in Elixir. That's because a live production system has dozens of different reasons why something can go wrong. The disk can fail, memory can be corrupted by some X-ray from outer space, bugs, network may stop working for a second, etc., etc. Just dozens of things that can go wrong. If we were to write software that attempted to protect all of those errors, we would spend more time handling failures than writing our own software. Yeah, for example, imagine your computer, router, printer, or whatever device is not working properly. What you do? You restart it. Because what it does, it goes to the known initial state, where everyone knows that it's going to work from this state. That's how we usually write programs in Elixir as well. It's also fine, like in production, even if you wrote lots of guards for your module, you never know what exactly data can come into that program, and it can fail. So and it's fine. You just need to have some decent monitoring and catch that issue. And if it's repeated issue, then you are going to the code and fix it. That's all. Let it crash is a common philosophy when writing Elixir programs, Elixir software. Probably we are just on time. That's great. But I wanted to, first of all, do you have any questions?
What about how executable file looks?
It's getting compiled to some binary to their internal format. So it's getting, the extension is .beam, and it's some binary. So some hacks inside. Though I wanted to address one thing that you told me before, Alan K. Let me just open the link. It's gonna be look better with the link. So, can you remind everyone what you just told me at the end of the first part of this session?
Most of this code looks like some object-oriented code, just with single object and global object. Is it supposed to be so?
You can so. It looked like it's a singleton object when we were working, and it was intentionally done like that. You can have just multiple objects, processes. The important thing, you know who is Alan Kay?
Yes, I do.
And in 1998, Alan Kay, on Saturday, October 10, so it was 25 years ago, he wrote, "Folks, just a gentle reminder that I took some pains to try to remind everyone that small talk is not only its syntax or class library, it's not even about classes. I'm sorry that I long ago coined the term objects for this topic, because it gets many people to focus on the lesser idea. The big idea is messaging. That is what the kernel of Smalltalk Squeak is all about." So I came to this conclusion even before I found this information. So at some point, writing Elixir programs, tinkering with OTP library, with processes, sending messages, I caught myself like, oh my god, I have something in the memory that is running, expecting messages, and responding to these messages accordingly. Is it how supposed OOP work?
Yeah, exactly.
Then I started to research this, and I found that. So
What's also funny, originally, like, yeah, OOP was the dynamic dispatch. So basically, C++ and Java bastardized the idea. So, yeah, like,
So yeah.
that's what we have now.
You got that feeling even much faster than me, or maybe just because I also consumed that before and I found the gist. But yeah, this is exactly in my head how it is supposed to be. So when I'm writing programs in Ruby right now, I do not trust the code I see. I do not trust the code I write. I know that, okay, this function, it can receive this argument, but this argument is object. And if some other thread changes sends a message to that object while this function runs, then you never know what happens. In Elixir and Erlang, the best part that this processing of messages is kind of atomic. It cannot be split in between. So while the function has not returned the value, you cannot do anything to what it works with. So that's why immutability is so important. So the function receives something and it's not mutable. Nothing can change the world, this little world for this function. It works with immutable data. That's the best part. When I write code in Elixir, when I read code in Elixir, I know what's happening and what's supposed to happen. No unpredictability. It really helps a lot in understanding what's happening in the program. So, yeah, so thank you very much.